Okay, this is day 2 of solving exponential and log functions. So I'm going to try to keep this one a little shorter and maybe skip around a few examples. When you have log of a base that's not base 10, you can either exponentiate each side or rewrite it in exponent form. So you can rewrite it in exponent form. So like this one, 4 to the x power equals 8, and then take the log of both sides and use the property of logs that says that exponent comes out front. So x times the log of 4 would equal the log of 8. Then divide both sides by log of 4, and x equals the log of 8 divided by the log of 4. And now I have base 10 properties, so I could use my calculator to evaluate that. Now I had it open here, got about 1.5. So 1.5 for that one. Oops. Let's see, where am I at? Sorry. 1.5. Or you can use the change of base formula that says that if you have log base b of x, for example, that's the same thing if you change it back to log base 10 of log of x divided by log of b. So it just changes it right back. The big one goes on top, so you got log of 4, and then the base goes on bottom, log of 12. So log base 4 over log base 12, and that's approximately equal to 0.56. Approximately 0.56. Exact answer. Remember that if you have the same base, then the exponents must be equal. So if the same base, the exponents must be equal. Now, sometimes it's obvious, like when we had, 2 to the x equals 2 cubed, then we knew that x equals 3. Sometimes it's not as obvious. So 2 to the 4x power equals 32 to the x minus 1. We don't have the same base, but we could make these bases the same because I know that 2 to the 5th power equals 32. So I can rewrite this as 2 to the 4x is equal to, instead of 32, replace that with the 2 to the 5th, and that's to the x minus 1 power then. So the 32 is replaced with the 2 to the 5th here. Now my bases are the same, and then I can set the exponents equal and finish solving. So then if 4x equals 5 times x minus 1, I do need to be careful that I remember to take that exponent of 5 to both, so I have to use my distributive property. So I have 4x equals 5x minus 5, and I need all my x's on one side, so I'm going to start by just subtracting 5x on both sides, and it's going to give me a negative 1x equals a negative 5. Divide by negative 1, I get x equals 5. We do have to watch out for extraneous solutions in these types of problems. So go back up to the original and say 2 to the 4 times 5 is going to be 2 to the 20th power. Is that going to be the same thing as 32 to the 5 minus 1 or 32 to the 4th power? Well, 2 to the 20th really is the same thing as 32 to the 4th because it's 2 to the 5th to the 4th. And remember, you multiply when you have power to a power. So 2 to the 20th does equal 2 to the 20th. Another method of solving is taking the log of each side. So I'm going to do the second one. This is a review from day 1. We did ones like that yesterday or in 9.4a notes. So I'm going to do number 2 here because it's a little bit more tricky. So the x is with the 5, so the first thing I need to do is get rid of the 3. So I'm going to take minus 3 from both sides, and I'm going to get 25 minus 3 is 22. Now I can take the log of each side because that will undo the exponent. So I'm going to take the log of both sides. Then this exponent comes out front. So I'm going to get x plus 2 times the log of 5 will equal the log of 22. So this is x plus 2 times the log of 5. I need to solve for x. But before I can do that, I need to get rid of this log of 5. So I'm going to divide both sides by the log of 5. Because that'll cancel this, and I'll get x plus 2. I don't need the parentheses anymore. is equal to the log of 22 divided by the log of 5. Then one more step to solve for x is to subtract 2 from both sides. So x is going to equal, I can't combine these because they're not like terms, so it's going to be the log of 22 over the log of 5, and then just that minus 2. So this is my exact answer. If I wanted to approximate that, I'd have to use a calculator here, and it would look something like this. Like you would have to do the log of, I can't remember what it was now, log of 22 divided by the log of 5, and get that answer, and then subtract 2 from that answer. And approximately negative 0.08. Negative 0.08 is the approximate answer. So be careful when evaluating that or how you're writing it. So that was when we take the log of each side because we had something to a power. If you have a log situation, if the logs are the same, like log base 4 and log base 4, then what's on the inside must be the same. So you would set x plus 3 equal to 8x plus 17 and then solve for that. Just make sure that when you're done, you check for extraneous solutions. I'm going to move my x's to the left, and I'm going to get negative 7x plus 3 equals 17. Subtract 3 from both sides. Negative 7x equals 14. Divided by negative 7. I get x equals negative 2. Plug that back in. I'm going to get log of negative 2 plus 3 is going to be log of 1. Does that equal log base 4 of 8 times negative 2 plus 17? That's going to be negative 16 plus 17 is going to be log base 4 of 1. So it checks out. Just checking for extraneous solutions. If you think about the parent function, log base b of x equals y, the horizontal asymptote, since our shift is at 0, 0, we have a vertical asymptote at x equals 0. And so our domain is x is greater than 0, which means that you can't evaluate a log of a negative number. So if you plug it back in and you got log of negative 2, that's you can't have that. It's undefined at that spot. So you can't take a log of a negative number. So because b to the y power equals x, b to any power will never equal something negative. So, okay, you can exponentiate each side of an equation. So, for example, you could take this as base 4, so you can take the exponentiate 4 to both sides, because that will undo this part. You'll get x plus 3 equals 4 squared is 16. Then you can continue solving. You're going to get x equals 13. If you plug that back in, you're going to get 13 plus 3 is 16. 4 squared is 16. That works. Over here, before I can exponentiate, I will need to get rid of the 4 out front. So you get log base 3 of 3x equals 5. Sometimes it's easier just to rewrite it. Instead of doing 3 to both sides like this, you could rewrite it when you get down to this as 3 to the 5th power equals 3x. Then you just divide by 3 on both sides. 3 to the 5th power is 243. Divided by 3 is 81. So x equals 81, I think. Some mental math. So hopefully that's right. If I plug 81 back in there, I'll be okay. No negatives. So that was kind of a quicker version of what we did yesterday. So day 2, just practicing a little bit more with a couple equations that have a few more extra steps. So hopefully that was helpful.